Hello, this is Miss Moore, and today during chemistry we're going to discuss characteristics of gases. This is the first part of a two-part lecture. So today's essential question, what are some characteristics of gases? Before we start talking specifically about gases, let's talk about the three states of matter and how they differ. So the three states of matter are solid, liquid, and gas. There's also plasma. We're not going to talk about that. We're going to stick with solid, liquid, and gas. Okay, solids. Shape and size is not dependent on the container the solid is in, which means that solids have both a fixed shape and a fixed volume. So if I were to take some sort of solid, let's say an ice cube, we'll use water, because it can be in all three states of matter. So if I take an ice cube and I put it in a cup, it's still ice cube shape. It's still ice cube size. I take it out of the cup, lay it on the table, it's still ice cube shape and ice cube size. So the shape and volume are not dependent on the container the solid is in. And this is because particles of a solid are closely packed and held together tightly. So they have a rigid structure. Okay, the atoms that make up, the atoms and molecules that make up the solid, in this case ice, are not free to move. Okay, state of matter number 2 is liquid. Liquids are slightly different than solids in that the shape of a liquid is dependent on the container the liquid is in, but the size or the volume of the liquid is not. Okay, which means that liquids have a fixed volume but a variable shape. Okay, the volume is the amount of space something takes up, how much of it there is. Okay, so you can't change the volume of a liquid, but you can change the shape. So if we now use, as our example, water in a cup, say I have exactly 1 cup of water in a cup. Well, then I have a cup of water that's cup-shaped. If I take that water and dump it out on the table, I still have a cup of water, but it's no longer cup shape, it's now table shape. So the amount or volume of water remains the same, but the shape is variable. The shape of the liquid is the shape of the container it's in. Okay, and this is because particles of a liquid are in contact with each other, but they do have some freedom to move. So they have what we call a fluid structure, and they can take on the shape of its container. All right, and the third state of matter is the gas. Gases are very different than both solids and liquid because both the shape and the size are dependent on the container the gas is in. Okay, which means gases have a variable shape and a variable volume. Okay, so what that means is that if I had a sealed cup, I had a cup filled with gas, let's say steam, liquid water, or gaseous water, and I put a lid on it, that the steam particles, the water particles will be bouncing around, like in this picture here, filling up the entire cup, and they would be cup-shaped. If I then opened up the lid on that cup, the steam would then, or the water in the gas form would then come out of the cup and bounce around and take up all of the space in my house or in my classroom or wherever I may be. So gases can change their volume, the amount of space they take up. In fact, gases will take up as much volume or as much space as you give them. And they can change their shape. They take up whatever shape of container they're in. And this is because particles of a gas are not in contact with each other, so they can move freely. So they take the shape of the container they are in. Gas particles don't actually really like to be close to each other, so they're going to move, they're going to spread out as far away from each other as they possibly can, taking up as much room as they possibly can. Okay, we're now going to talk about a few characteristics of gases now that we know kind of how their molecules move. All right, so first thing is that gases are fluids. Now, fluids don't mean liquids. Fluids mean something that flows, and both gases and liquids are fluids because they flow. So gases flow like liquids. They exert pressure equally in all directions on the container. This is because the gas molecules, remember, they're not connected, so they keep moving around. They're bouncing off the walls and off the floor and off the ceiling and just bouncing. So they're going to be pushing equally in all directions. Gas molecules are in constant motion. They're really, really hyper, and there's nothing holding them down, so they just move. So they collide or bump into each other all the time. These collisions are elastic. Now, what an elastic collision means is it means that it'll bounce off something and ricochet off with the same amount of energy, the same amount of speed. Okay, so a non-elastic collision would be like two cars smashing into each other. They bounce off each other, but they bounce off each other at a much slower speed. They have lost energy due to friction. Okay, that's a non-elastic collision. That's not what happens with gas molecules. Gas molecules slam into the wall and bounce back, going the same speed. Think about your dream Super Bowl. If you remember a Super Bowl, you're in an empty room, all the way closed, and if you could throw that ball and it bounce, never stop. That would be elastic collisions, and that would be what gas molecules do. All right, density of gases. The formula for density is mass divided by volume. So density is really looking at the relationship between how much something weighs for its volume, the amount of space it takes up, how big it is. Okay, so something that's very, very dense could be very small but heavy. Something that's not very dense could be very large but light. Okay, so gases have a lower density than either liquids or solids. And this is because gases are mostly empty space, because the gases are spread out as far as they can go. That's not true of the molecules making up solids and liquids. Gases can be compressed. Okay, they can be squished closer together. Why? Because gases are mostly empty space. So you could gather those gas molecules up and squeeze them closer and closer together, because they're far apart. If you think about a solid like ice, it'd be really hard to squeeze ice and make it smaller because it's not mostly empty space. And that's it for this part of the characteristics of gases lecture. We'll continue with this with characteristics of gases lecture, part 2. Have a good one.